Hey everyone, welcome back to the channel. Today we are tackling NDVI Change Detection, and by the end of this video you are going to understand exactly how satellite can tell us whether vegetation across an entire province is growing or dying using nothing but free data and Google Earth engine. So we are going to build this using Sentinel-2, Imagery, cloud masked composite and fully interactive app. And our study area is Punjab, Pakistan. Let's get into it. Before we touch any code, I want you to actually understand why this works, not just copy paste it. Here's the core idea. So, healthy plant leaves behave in a very specific way. So here is the mention that this reflectance contrast is a physical basis of every vegetation index in remote sensing. So it's the physical foundation for every vegetation index used in a remote sensing. Uh, Means that once this clicks, everything else in this video is just math and code built on that. Okay, this one, reflectance contrast, is near infrared versus red, is the physical foundation of every vegetation index used in remote sensing. So once this clicks, everything else in this video is just math and code built on the top of this idea. So this is the main core point over here. Okay, so scientists took that reflectance contrast and turned it into a single formula, NDVI, and that is equals to near infrared minus red and near infrared plus red. On Sentinel-2, near infrared band is band 8 and the red is band 4. So we will work only with those both bands. So here's how to read that scale. So values near -1 means that there is some water, maybe snow, or maybe some clouds. When it is from 0 to 0.2, maybe bare soil or urban. Or moving on to onward, when it's from 0.5 to 1, there may be a dense vegetation or maybe really healthy vegetation. So this is how we read NDVI. Now here's the second idea, and it's honestly even simpler. What if we calculate NDVI for the exact same location at two different points in time and just subtract them? NDVI at time 2 minus NDVI at time 1 gives us what we call delta NDVI, our change map. So that is something we're gonna do in our app development. And the interpretation is initiative. A negative result means vegetation loss, red on our map. Near zero means basically no change, and a positive result means vegetation gain, shown in the green. So this exact technique is what researchers use worldwide for deforestation monitoring. Now let's talk about the imagery, about the Sentinel-2 that we're going to use to build our app. A few numbers worth knowing, because there are two satellites working together. We get a full revisit of any point on Earth every 5 days by Sentinel. These visible and near infrared bands come into a 10-meter resolution and detailed enough to distinguish individual from bands. We have 13 bands of Sentinel. So, and critically, all of this data is completely free and publicly available. Okay, so here is the complete picture of what we are building in 6 steps. So first of all, we will define our area. In the second step, we will select 2 time periods for our app development. Like first is maybe 2017 and the second would be maybe 2024. Then we have a cloud mask function that we will apply on the imagery of Sentinel-2 by computing NDVI. Then we have a subtract for change, like we will subtract NDVI time 2 minus NDVI time 1. And then we have an interactive 2 maps that will be split. One is showing the previous time and the next is showing the updated time. Then we have our result, and with the result we have an export function. We can export it as a GeoTIFF or maybe as a PNG. So this is how we're gonna build our app, Google Earth Engine first app for NDVI. So let's get started. Okay, so here is the app we are building today, and I want you to see the whole architecture before we touch single line of the code. Define our study area Punjab, Pakistan, down to the district level too. The user picks two time period, say March 2019 and March 2024. For each period, we pull Sentinel-2 imagery, mask out clouds, and compute NDVI, and subtract the two to get the change map. So here's it work. The first one I will select 2021, and the second could be I select 2026, and the months are July. So show NDVI. So first of all, it will show me. So here's update analysis option. So when I update it, so the second one is 2026 and the first one is 2021. So it will take some time to load it. Let's see how the result will come. So we have a 2021 imagery over here and the 2026 imagery over here. So we can clearly see the changes. The 2026 imagery is somehow distorted. We also have legends over there. So now let's create this type of app by ourselves. So let's get started. So first of all, what you need to define is your global administrative boundaries collection that have already loaded in Google Earth Engine. We just filter it down in two steps, first to Pakistan and then to Punjab province. You can define your own country and your own province. I also pull a second more detailed layer. So district level boundaries, because later we will draw those as thin reference lines on our map. The same way a printed atlas shows internal divisions. So that's why I have used. Then I have used dot filtered operations because animation the filter narrowing. So world map narrow down to Pakistan, and then Pakistan is narrowed down to just Punjab. So this is the code for the study area that I am going to use in my app. So let's get moved to the second block, that is for, okay, so this is our second step, and in this second step we have, let me clear it. Okay, so we are defining global variables. We auto generate a list of years from 2017 to onward when Sentinel-2 data becomes reliably available up to the current year. So the drop down always stays up to data without hard coding. We do the same thing for months, and here are the months, and we define two color palettes. Here are the two color palettes, one that goes red, orange, yellow, green, dark green for showing raw NDVI, and simple red, white, green palette for showing change. So red for loss, green for gain. So that's how we define our global variables. In the first we have defined our years, and then we have defined our variables as months, and months have all the months listed, and then we have defined some of the palettes. So our first step is defining our study area, and then the second step is global variables, where we define the year, the months, and the palettes. So let's get move into the next step. Okay, this is our third step, where we're gonna do the cloud masking. So here we have used the SCL. So remember the SCL band from the earlier. So here's where we use it. Values 3, 8, 9, and 10 and 11 correspond to cloud shadow. So here these are the values that correspond to the cloud shadow. Medium and high probability clouds, cirrus and snow. We build a mask that exclude all of those, apply it to the image, and divide by 10,000, because Sentinel-2 store reflectance values scaled up as integers for storage efficiency, so we convert them back to the proper 0 to 1 reflectance range. So that's how the cloud masking function of Sentinel-2 works. In the next step, we're going to calculate the NDVI. So let's calculate NDVI. We will apply the formula of NDVI. Okay, so here is the formula of NDVI. This is our block 1 formula written in Earth Engine language. Normalized difference. So it's the built-in shortcut that does exactly what we have discussed. Near infrared minus red divided by near infrared plus red. So band 8 is the near infrared and band 4 is the red. So one line of code, years of remote sensing theory. So that's how NDVI formula work within the Google Earth engine. Okay, so our next step is get NDVI composite. A single satellite pass might still have some cloud gaps, so instead of using one image, we gather every Sentinel-2 image over our chosen month, filter out anything with more than 40%, for example maybe cloudy pixels, and mask remaining clouds and take the pixel by pixel median. So here's we're gonna take it. The median composite fills in the gaps automatically. If one pass was cloudy over a village but another pass wasn't, the median uses a clean pixel. So we also added a safety check. If literally 0 images exist for a month, we fall back to the blank image instead of crashing the app. So this is how our NDVI composite gonna work. So animate 5 to 6 images with the titles, stacking and merging them into one clean tile. So that's how the NDVI composite works. So let's get moved into another step. Okay, so next we will define the map setup, all the important things of that. So first we have the left map and then we have the right map. This is our first map and this is our second map. So the left map and the right map uh, shows the default map control like zoom button, layer button, map type, drawing tools and everything. For that we have. So without this they can be hidden. So we are synchronizing both maps. Whenever you zoom, pan, move one map, the other automatically moves. So this is how they are linked to each other. So if you are moving the left map, the right one will also move with that. So that's how it will work. So then we have a variable, the split panel, and it will create a panel containing two maps, like splitting both the panels. So we have a left map and then we have a right map. So this is how it's gonna work. So we are defining there that wipe is true. So it enables the swipe comparison. So like before and after imagery, you drag the divider. So here is the style, and then we have a user interface root clear and then user interface root dot add. So what does it mean? It adds the split map to the application, to our user interface. So it's basically adding these all things into the user interface. Okay, so next we have a legend function, and what it's gonna do, it create a reusable legends. So we are talking about this section, and this also gonna be really lengthy, but we will learn it from one by one functions. Instead of writing legend code twice, you write it once and call it whenever it needed. So this is how functions are really good. We can define it in once and then we can call it later wherever in the code we want. So we have defined a variable that is legend, and then we have a user panel. So it's create the floating panel. So when we have defined the position, we have a position there bottom left. So it's Java is really easy. We are defining it in a really simple language. It's just really saying that bottom left. So it will understand that I have to be in the place of bottom left. So that's how it works. So padding is equals to 10 pixels. It will add some spaces inside the panel, and then we have a background color, what we background want for it and what we width want for it. So we will define all of these properties or these parameters for our legends. And then we have a legend title, and we are saying it legend title, it must be bold and it must have font size at 16. So that's how we define it. And then we have a color bar with the legends. So we are defining the color bar variable for our legend. This is a trick. This is not a built-in legend gradient. So Earth Engine create a tiny image. image type so that we can understand it easily. So that's how it's gonna work. So we are using this image EE pixel. So what that means is create a horizontal image where values go from 0 to 1. So it's a picture type of thing that we have created in Google Earth Engine. That's not the original legends. That's we are just defining it and making a sense of it. That's it. So then we have defined some of the palettes, and then we have defined the style, and then we have added all of these values, all of the above defined values in the user interface. So that's how it's gonna work. It return Earth's legends. So next is the most important thing, that is north arrow. And for north arrow, we are again defining a function named as add north arrow, and inside it we have a map panel. So it will create a reusable north arrow. We can call it anywhere we want inside the code. So first of all, we have a map panel dot add user interface label. So what it's gonna do, it will add this thing into the map, and then we have defined some of its properties like that. It will look like a real north arrow. For example, we have defined its position in the top right, then we have a font weight, then we have font size, background color, and padding. So we don't have a north arrow originally as we have in the softwares like ArcPro and QGIS and other GIS softwares. We don't have an arrow, inbuilt arrow over there, but we have built it like it will looks like real. So that's how north arrow gonna work in Google Earth Engine. And then we have a scale bar again. It adds a small scale label. So it is not a real dynamic again. It simply says scale approximately. A real scale bar would calculate distances. So this is how scale bar gonna work in our app. And then we have a control panel. Now I will define step by step how these codes will work. So first of all, we have a variable that is control panel, and it will create a sidebar. Like we have a Punjab NDVI app, we have a title, then we have a year to select, then we have a month option to select, then we have other options. Like this will work like that way. It will create a sidebar. With the width, we have defined some of the padding, its position. We want it in the top left. We can also change its position, and then we can define its background color. So this portion is for our left sidebar, all the options that we are going to define inside. Okay, so what we want inside is we are defining over there. First of all, we have defined the title. We want its title as a Punjab NDVI Change Detection App. So we have also defined font size, font weight, and color, all of that. So it will add in the left panel, in the left side, we have a title that is NDVI Change Detection App. So our title is added. And next we have a year selection option. We have a variable year select one. Like it will drop down. It will create a drop down like from 2017 to onward 2026 or 2025. Select a year, and then we have another option, select a month. And then there is another option, select the second year. Like you want the difference of the first year and the second year, then define your second year. And then also and then we have another variable that is view toggle. It will show it will have two buttons, show NDVI or show change. So if you click on show NDVI, so it will show you NDVI, and if you're clicking on the show change, then it will show you the change. And then we have the last but not the least, status label. So how it's gonna work, it displays the current status, like later changes to processing or analysis updated, something like that. It's gonna work it like that. So this will show you the things like that. So this is how control panel works. We have just created our left sidebar. We have added 3 to 4 things. First, we have added the control panel user interface, what its background, what its padding, its weight, its position, top left. And then we have defined our title, then the first year of the first time of the NDVI, then we have selected the month, the first month, or the out of the 12 months, whatever the month you're gonna select. And then we have the second year, the second time, and then we have the month, and then we have update toggle bar of show NDVI and change NDVI, and the last we have the status label, like what is the status of your analysis. Okay, so next step is update map. We have defined some of the update map over here, and then we have a update function over here, full function of processing or whatever it is. Let's see it one by one. This is the heart of the application, like how whenever user change date clicks update, this function run. So if you will not click this function, your update function will not gonna work. So this is the function that gonna show you the processing, and it is for the left map, it is again for the right map, again the weights for the left map and the weights for the right map. So when I will say it like that, the reset function will remove all the previous map layers, and it is same for the right map. And then we have the left map, the reset function will delete all of the previous legends and labels, and same for the right map. So this is how gonna work. So what this function meaning is, get the selected year. For example, if I have selected 2021, it will give me the imagery of the 2021, and if I have selected the 2022, it will give me the imagery of 2022. So this is for this first time and the second time, and again goes for this months, like all the months, for the first month and for the second month. And this is a function for computing the NDVI, like it works like it return you monthly NDVI image, same for the second month. So the thing that we're going to use for the first, we are also using it for the second, but as our year or our month would change, so this will also change. So we have another variable that is change, so it will subtract our second time imagery from the first. So it will subtract NDVI2 from NDVI1 and rename it as NDVI change. That's how it's gonna work. And these are some of the visualization parameters for our app. Okay, and then we have visualization, like how we're gonna see NDVI. We are just defining the colors that we have defined in the above, and then we have same for the change visualization. We have defined the minimum and maximum value, and then we have defined the change palettes in the above code, and we are just calling it there. So this is the if function, if from here to there. It is if the user selected show NDVI, so it will just display you the map 1 NDVI1 and the map 2 NDVI2. Otherwise it will display you the NDVI change. So this is how it gonna work. Then we have a left map and then we have a right map. So how it will work, like it's just defining you the Punjab boundary. We are just adding the Punjab boundary into the map, and we are defining its color, its fill color, its width, and it is renaming it in the left map and in the right map. We're just defining both of them. So we have Punjab boundary on the left too, and then we have Punjab boundary on the right too. And then we have a district boundary over here. Then we have the data labels. So how data label is gonna work, it will display the date on the left map, and this will display you date or year on the right of the map. For example, it's saying year one is, for example, 2020. The left map is showing you the 2020, and the right map is showing you maybe 2026 if you have selected. And all of that are the properties inside it. Like we want position, font weight, we are discussing its font size, background color, and padding. So these are all the styling properties that we are going to give to year one labeling. So these two are for the labels of the left map and the right map. Then we have added the north arrow on the left map and on the right map. So instead of rewriting the code, we have used add north arrow. So this is a function that we have defined in the above code. We are just calling it and adding them on the maps. So we are also adding the scale bars on the left map and the right map. We have defined all of the functions in the above code, and we are just calling it one by one over here and adding them into the map. So we are also adding the legends. So this is the function to add the legends again. So when the analysis will update, so the year and the legends or the title will also change. So it will update according to our updation. And then we have the export function. So what will it do? There is a function export current map, and what will it do? It will export our current results, and what we will get is selected year, selected month. Again, it will calculate NDVI 1, NDVI 2 and change. So here's the NDVI 1, 2 and change. We can get all of the composite for that. And the final variable is export the image into the drive. So this will export our image to the drive. And then we have a if function there, if PNG mode. What it do is, if it's true, convert raster into color image, because PNG cannot store the raw NDVI values. So then we have the very easy function export dot image to drive. This is the basic function to export our images to the drive. So it will create Earth Engine export task, and this is the task name. The description is the task name, and we are naming it as Punjab NDVI PNG, or maybe Punjab NDVI in the form of TIFF. So and next we are defining the folder. We have the field name prefix, we have a region. The region is our Punjab. We have a scale, and we have maximum pixels 1A13. Okay, so now this is the last, not the last thing, but then we have worked on some of the buttons. Each button has some of the labels, some colors, some actions to provide. For building an app, it's really important to make the buttons. So when we click on it, it must be well representative, so that we can click on it, we can easily get the information that we want. Here is the title of the first button, update analysis. We have added one button, and then we have another button that is export GeoTIFF. We have defined also other properties, and then we have the third button that is export PNG to the map. So we have used three of the buttons over there, and also its properties to export our desired analysis into the drive. Then we have panel assembly. Like what panel assembly means, add everything weights into the sidebar, like title, year 1, month 1, year 2, months 2, view, buttons and status. So that's how it works. Like we have defined everything in the above code. Like we have defined the title, year, months, year 2, months 2, view. We have defined everything. Now we are just adding them in the panel. Just add all of them into the panel. Then we have a final user interface. Finally, place a sidebar before the split map in the root user interface, so both appear together. And the final initial load, like runs the application immediately when it starts. So now let's run the app and see how it looks. So this is how our app look like. It's showing me 2026 for both of them. So let's change the date of the first. Let's select it 2019, and this is 2026. Let's make from July to January and show NDVI. So these are all the buttons that we have added in the user interface, and this is the title that I've talked about. So we have the NDVI. Okay, we didn't update the analysis, so this is the option. When you click it, it will activate and it will show you the NDVI over here. So we have 2019 NDVI and 2026. So let's see the difference between them. We have the three layers: the district boundary, the Punjab boundary, and NDVI time 2 and time 1. So as you can see, we have a very lush greenery over here, and we don't have a lush greenery over here. One of the reason for that is this is for the January, and let's make it January 2 and update it. Okay, so now almost it's visible, and you can clearly see how vegetation is changing. Like you can see, this is the highly vegetated area at some time, and then we have no vegetation over there. Look, in 2026 we have more vegetation than 2019. Let's see the change analysis. Okay, so this is how NDVI look like of both the maps. You can do this for your small district. If you want to do this, you can just change your study area from the very top. From over here, you can change your country and you can change your district, or you can also do this for the small level. Like I have used the level 1 and then I have used the level 2. You can also use the level 3 and level 4 up to the small levels. Let's see the change, show change and update analysis. So the areas that are most affected are these. We have almost the same, and as if we have very little change for both of the years. Okay, so now you can see the change. If you further zoom in, you can see the more changes that are happening. So this is how you can create a map. So if you want to make app for this, you can just go to app. So you can also say create a new app, and from cloud project you are using this. Next, and then you can create your app name. For example, I have created NDVI Change Detection, you can say this. And then next, current content of the editor, yes, and just you can say it publish. And then when you publish it, after 30 to 40 minutes it will give you a link, then you can directly open it there. Like I have already created it, so let me open this. So this is my app. Now you can't see any code over here. It will not show you code, it's just an app. It's just give me the options to select the years, different months, and then it will show me all the data. So this is how apps gonna work in Google Earth Engine. Hope you find this video interesting. Okay, and that's how you can build a complete NDVI change detection application in Google Earth Engine with synchronized maps, interactive control, legends, and change analysis and export functionality. I hope this tutorial helped you understand not only how to write the code, but also the concepts behind each component. So if you found this video useful, please guide it a thumbs up, subscribe to the channel, and turn on the notification bell so that you don't miss future GIS and remote sensing tutorials. So if you have any queries, suggestions, or ideas for the future project, let me know in the comments below. I would love to hear your feedback. Thank you so much for watching, and I'll see you in the next tutorial. Happy coding, happy mapping.